Hypothesis is a property-based testing tool for Python programs. Property-based testing is a testing approach in which you specify the properties that a system should satisfy, and then test cases are automatically generated to test these properties. The tool Hypothesis is simple to set up and use, and is also well documented, well maintained, and frequently updated. Hypothesis can be integrated with other testing frameworks like PyTest, and this makes it simple to incorporate into existing testing workflows. This tool is useful for efficiently finding and testing edge cases, as well as input verification. By automatically generating large amounts of test data and exploring a broad range of input values, we do not have to manually program them, making testing easier and faster for programmers. It is very versatile and can be applied to small and large-scale Python programs. It uses randomized testing strategies and also has a shrinking mechanism for minimizing test cases, and even adds bugs found to a database to test next time. Hypothesis explores a wide range of inputs and is an excellent complement to more traditional example-based testing. Here are some uses of Hypothesis and some things it can't do very well. The ones in bold will be demonstrated in our code examples.
Here we have a quicksort algorithm which we will be testing. Firstly, we want to check that the list is in a sorted order. And to do this with Hypothesis, we are going to use the @given decorator, which specifies the input to give to the method to test. We are also able to specify the min and max value of these if we wanted to. Next, we have @settings, which allows us to tweak the way Hypothesis works. For example, we can set the maximum number of examples to run. Finally, the @example decorator allows us to specify an example to always use in the test data. The next test checks for length and uses the keyword assume, which gives us the ability to restrict the data further. And to run the test, we use the following command in the terminal. And as you can see, both tests have passed. Next, we have a bad example which will not pass the test. When this test is run, we are told that there was an error where the input was the array 1, 0, and it also says which line that it has failed on. We can then investigate our code to figure out why this error was thrown.
Here is an example of code that we want to test. Hypothesis features a command called write that automatically generates some tests, shown here. These can then be cut and pasted into the code file, which obviously hugely speeds up the testing process.
So here you can see a more complex example of using Hypothesis to test a program, and this program here is used to simulate a box of chocolates, and there's a random selection of chocolates in each box, with the exception of the cherry chocolate. So in each box there's only one, and you can also eat a chocolate, but you only eat the cherry one if it's the last one in the box, otherwise you eat a random one. So in terms of testing this, I have used a user-defined strategy, which is something new that we haven't showed yet, and you can see it's got this composite decorator, and what it does is it creates a box of chocolates of a random size, and you can see that it picks a value between the minimum size of 1 and max size of 10, and it chooses a random value in this range and then makes a box of chocolates of that size. And this strategy can then be used in our tests. So you can see here that we've used this choc boxes strategy here and here in these tests. We specified a minimum size of 1, we haven't specified a maximum size, and this is used to then test the code using this strategy, which gets a box of chocolates from this strategy, and it saves us having to write this code in every single test. So it encapsulates the logic for making a box of chocolates here. So you can see that when we run these tests, they all pass.
This is an example of a program that uses concurrency. It simulates a race, each thread acting as a participant who moves forward a random amount when each thread is allowed to run. It includes a race condition in the form of a global variable, which tracks the leader in the race. which each thread is allowed to update without the correct synchronization. The tests attempt to identify it, but as you can see, all the tests pass without any issues, demonstrating that the bug cannot be discovered by Hypothesis. Hypothesis is sometimes able to identify problems in programs that feature concurrency, but it is not designed for it and often misses things. This is the code for the weather app. It automatically detects the user's location and gives out today's weather, including additional information such as the time of sunrise and sunset. The code is written on Flet library, which is the Python library for developing mobile applications. It extracts the weather information from the server. It first uses Hypothesis to check that the list contains weather information of the correct type, length, and only contains integers and floats. We can check that it works correctly by, for example, changing the assert statement, which checks the length of the result. As you can see, it doesn't pass the test because its length is different. It is then used to check that the additional information mentioned above is of type list, and that it has the container in it, which in turn has the sunset icon and time. The second test function tests that the result container is of correct type, size, and that it is not empty. The third one does the same for the other container, but additionally, it checks that its padding is correct.
To summarize, here are some advantages and disadvantages of using Hypothesis. So for the advantages, Hypothesis generates test cases automatically, which speeds up testing. It also supports observability tools, which can print drawn values randomly during falsifying tests, which helps in debugging. It uses targeted property-based testing, combining property and search-based testing advantages, enhancing the generation of test cases. It can also be useful in machine learning for result significance assessment and model validation. And for the disadvantages, using Hypothesis effectively might require some learning, especially for those who are new to testing. It is powerful, but it is not a one-size-fits-all solution, and it might not cover all testing scenarios. Testing in Hypothesis relies heavily on defining accurate properties, which can sometimes be challenging. And finally, generating complex test cases can be computationally expensive and might take longer to run, which can be frustrating for developers. Overall, Hypothesis excels at uncovering hidden bugs, demonstrating why it's widely embraced by industry professionals.